All right, so just a quick show of hands before I start. So I have a feeling of who my audience is. How many of you guys have used CHPC before or current users? Okay, so there's a few of you in the audience. So some of you already probably know what we offer and who we are. I'm really going to try and motivate today sort of why, as a deep learning practitioner, a researcher, student, you should consider using us. I think we offer some fantastic resources, and I often say we're one of the best kept secrets in South Africa. So the fact that we exist doesn't seem to be well known, and it should be much better known. All right, so my name is John Poole. I'm here representing the CHPC. And I'll just give you a little bit of a background of who I am and also introduce you to one of my colleagues who's also here, since you'll probably be interacting with him more than you'll be interacting with me. So I'm officially employed as the Bioinformatics Service Platform Manager. So at CHPC, I look after people in the life sciences, medical sciences who need access to supercomputing resources. My training and background is quite varied. I'm an electronic engineer. I did my PhD in physics, and then I've moved from there into the life sciences, structural biology, and bioinformatics. At the moment, I've also been the unofficial contact for machine learning, deep learning at CHPC, but unfortunately, that's only going to be for the next 2 weeks. So 2 weeks from today, my contract comes to an end, and I'll be moving on. So I'll talk briefly about that in the next slide, but I will introduce you, at least at the moment, to my colleague, Dr. Krishna Govender, who will be taking over as a lead. So he's the person that you're going to be dealing with. He's extremely competent. He's one of those jack of all trades. So he might be a computational chemist, but he knows a heck of a lot more than just chemistry. So one of the most useful people at CHPC, and again, the person who will be able to help you with many of your queries about actually making use of our system. All right, so I'm actually moving on. So yesterday I was teaching, so this is what my audience looked like yesterday, and that's probably what it will look like tomorrow. So unfortunately, contracts don't come to a nice clean end, so there's a little bit of an overlap. Again, one of the most exciting experiences I've actually had. So if any of you guys get disillusioned with industry and academia, teaching is something South Africa needs a lot more of, and there's plenty of place to make a huge impact. Currently teaching at Wynberg Girls High School, and that's certainly some of the most amazing students I've dealt with, extremely motivated, well-behaved, and hopefully the next machine learning practitioners if I have any influence on them. So I'm looking at that as one of the possible outcomes. So first of all, let's just talk about what the Center for High Performance Computing is. We're part of NICI's, the National Integrated Cyber Infrastructure System, which was put in place by DSP to provide basically 3 main sets of resources to the country. SANREN, one of our partners, provides, SANREN is the South African National Research and Education Network. They provide the connectivity between all the universities and government science councils, so the internet backbone for that class of users in South Africa. Then CHPC, the Center for High Performance Computing, provides the big compute. So when you really need resources which are much larger than what you have available on your desktop or maybe even at a university cluster, this is who you should approach. And then, of course, we've also got DARISA, which is unfortunately the younger of the partners. DARISA stands for the Data Intensive Research Initiative of South Africa. And basically what they are going to look at is the long-term data management and storage. And that's actually quite a challenging task, but it's also one that I think all of us are very keen to see come online. So we're managed by CSR on behalf of the DST. And we cover all disciplines. Unfortunately, being a national facility, the only one in the country, we run the nation's supercomputer, and so we provide resources to any scientific and engineering domain which needs large-scale compute. We also provide resources to a wide range of users, so everyone from academics. Obviously, most of our users at the moment come from universities, but we also supply resources to the government science councils, and to private industry. So once again, we are not exclusively in the market just to the academics and the government, and we will talk a little bit about this later, because I think this is one of the best kept secrets as well. We provide for South African-based businesses, and we've had quite some success in this, in helping startups get off the ground. Okay? People who wouldn't have been able to do what they've done without our input. And so that's something that we will talk about a bit later, is how much it costs to use us. So really the first thing is, what is a supercomputer? And this is a key thing which I think many people miss. So the idea is that supercomputing is not just a super fast computer, it's really parallel computing. And in fact, I wish we stopped talking about high-performance computing and started talking simply about parallel computing, because that implies the type of jobs that will work well on our system. So really what I want you to take away from this is we basically provide a speed up under a couple of conditions. You need a really big job, okay, something that requires a lot of compute, or you're computing with very large data sets. If you have a tiny job, you're not going to see any performance. In fact, you might even see it run faster on your laptop. We do have people who are a little bit disillusioned. They come to us and they say, wait a second, this runs faster on my laptop, what's going on? Okay, the other thing is you need a type of job that can actually be parallelized. So not all algorithms, unfortunately, can be broken down in such a way that we can take individual parts of the job and send them off to other computers to be done at the same time and then put back together. And the software needs to be explicitly written to allow you to do that. So if you're not familiar with the parallel computing, terms like MPI and OpenMP often come up, and these will give you a hint that the code has been written in such a way that it can either make use of multiple cores, or potentially in the case of MPI, actually use multiple servers. So a parallel computer really is, or a cluster like we run, is a large collection of machines. And I'll start to talk to you just now about the actual specs of what we have. But at the end of the day, it is nothing more than x86 computers hooked together in such a way that they can solve a job cooperatively. Okay, it's not the cloud, and unfortunately, a lot of users, especially in machine learning, are very used to and comfortable with the cloud. There's no problem with the cloud. Basically, behind the scenes, it's very similar type of equipment that you're going to be using, but the way that you access it is slightly different. And I want to convince you that it's worth a little bit of pain getting out of your comfort zone to make use of what CHPC offers. Okay, all of our users interact with us remotely, so no one comes to Cape Town to use CHPC. And that also seems to be a common misconception when I talk to new users. They say, wait a second, I would come and use you guys if we were in Cape Town. Well, you can use us just as easily halfway around the world as you can sitting in my office next to the machine room. Okay, and we also don't do things interactively for the most part. That's not always the case, but in some cases we do run interactive jobs. But that's normally when we're doing some post-processing or visualization. For the most part, we allow the resources to, or the jobs to run in the background when the resources become available. We do support high-throughput computing. Again, that's simply because a lot of our users don't have what we call parallel jobs, but they have a large number of small jobs. And if they can do each of those jobs at the same time, as opposed to having to do one after the other, they get to the result much faster. So we do support that, and we do condone the use of that on our system. Again, I think it's well worth your time and effort to get involved with us if you have a job which would benefit from this. So what do we actually have? If you look on the ground, our prize asset is Lingao, which means cheetah in Setswana. And this basically is 32,000 plus x86 cores. It is a lot of cores. That's basically broken down. We've got 1,368 nodes. Each node is a separate computer by itself with 24 cores, and most of them have 128 gigs of RAM. Okay, so each node by itself is quite a powerful piece of equipment. We have a few of them that have slightly less, of about 64 gigs. But still very, very powerful compared to what most people have on their desktop, or certainly on their laptop. We have 5 fat nodes, which were purchased specifically for people doing de novo genetic assemblies, but again, they're welcome to be used by anyone else who needs a big memory machine. So these typically have 56 cores and 1 terabyte of RAM. All right, so the other thing that makes a supercomputer super is the fact that it's got a very, very high speed, low latency interconnect between these nodes. So when you're running jobs which use multiple nodes, this becomes very important. Otherwise, your CPUs are sitting around waiting for data to be shifted back and forth. So we have FDR InfiniBand, which gives us interconnect bandwidth of 56 gigabits per second. But now's the important part. So I think hopefully that's highlighted in red. So all of you guys with machine learning should be excited about GPUs, right? All right. So we have 24 NVIDIA V100 GPUs. Okay. These are highly underutilized at the moment. Computational chemists love them. So Krishna has a number of users who make use of these, but we see very few machine learning practitioners running, say, TensorFlow on them. And this is what I'd like to try and convince you that it's worthwhile investing a little bit to make use of them. Okay, they're divided up, so we've got 6 sleds with 2 GPUs each, and they have just the PCIe interconnect, but we also have 3 with 4 GPUs in each, which have the NVLink interconnect. Okay, so this is state-of-the-art stuff. And again, it's all available, and I'll explain in a few minutes how you get to use it. We also have a very high-speed parallel file system called Lustre. So 4 petabytes, this is not intended to be for long-term storage, but it's basically for people to process big data sets. And again, if you have a large data set and you have a lot of compute, you need to get the data to the GPUs and back. So if you don't have a high-speed file system, basically you'll spend a lot of time idling with your processing units, okay, whatever they are. All right, so this is something that I think, again, hopefully should excite you. I know sometimes talking about x86 cores to machine learning people is not what they want to hear. And we also do have a very fast connection to SANREN, so if you're sitting at a science lab, science council, if you're sitting at a university, you can move data to and from us at a gigabit per second. So CHPC is organized just in 3 teams. We've got management, who basically just deals with the contracts. The technical team, who you guys won't see as users much, are really the system administrators. So they talk or deal with the hardware and sort of keeping the system running. But the guys that you'll interact with are the research team. So one of CHPC's strengths, I think, is that we have a team of dedicated scientists. So these are people with expertise in particular domains. Unfortunately, we won't have anyone with, well, we'll have Krishna with machine learning. But these are the people that will help you actually make use of the resources. So certainly within bioinformatics, we find that most of our users who need to use bioinformatics may not necessarily have the background to effectively make use of what we provide. Software. Again, CHPC operates very much on a user-centric model. So we would like you basically to tell us what you want. So we don't just install software and say, take it or leave it. We want people to tell us what they want, and then we will install that for them. By far, most of the software is free and open source. Again, certainly within the bioinformatics community, which I'm most familiar with, I think everything is free and open source that we have. But we will install commercial packages if you have a license for them. We're not going to go out and buy you MATLAB, unfortunately. But if you have a license, we're more than happy to let you use it legitimately. There are some other national licenses, I think, often with the computational chemistry codes. And Krishna can obviously answer more about that, again, just for South African users. So once again, we don't run any Windows software or Mac software. Unfortunately, HPC Linux is the king. In fact, it's pretty much the only operating system. If you look at the top 500 supercomputers in the world, there's not a single one which is running Windows or Mac OS. They're all Linux. Okay, and we use a module system, so that's something that also trips up users. We've got a lot of software installed. People log on, and the question is, well, how do I use my software? Well, or do I need it installed? Yes, it's probably already installed, unless you're you're an outlier at this point, because we've had so many users make use of us for a number of years now that we've actually got quite a bit on the system already. The module system is just the way that we manage our system, so you have to load a module to get access to a particular package. So when would you want to use the CHPC? I think really this is about when you need to scale up. So again, if you're doing a lot of very small sort of development work, just playing around with tiny data sets, that's often more convenient to do at home. And CHPC really is out there so that we can scale up when you get to the point where you now are ready to run a much larger data set and you don't have those compute resources locally. So that's the key, is really do your development locally if you can. And then as soon as you don't have the compute resources you need, CHPC is the first place we think you should look. So with that said, what's the next question? Okay, well, we'll get to the how much as soon as we've covered how. Okay, we need to entice you first before we tell you, but I think, again, the pricing should also be very amenable to most of you. So the resources are allocated to research programs, not individual users. So that's key. A lot of people rock up and say, I'd like an account. Okay, we don't do that. What we do is we require a PI to register, so a principal investigator, to register and be sort of vetted. So and we'll sort of spoiler alert, I mean, we give a lot of resources away for free. So we also need to be very careful to ensure that we know who's on the system and what they're doing, especially when they're using it at no cost. So the PI is typically a faculty member, someone with a permanent position at a South African academic institution, or at several of the SK partner countries. We treat them exactly the same as South Africans, in terms of their access to the system. So they will take responsibility for a research program. We will allocate resources. And at CHPC, when we talk about resources, we're talking about CPU hours only. We don't worry about the amount of disk space you use, except we would like you to keep it to a minimum, but we don't actually charge you or, I would say, monitor that per se, or network bandwidth. So you're free to transfer data in and out of CHPC at will. Then we have regular users. Now, these are the people who typically do the work. A PI can be also a member of his research program, but a PI will add users. So these users the PI has vetted, they are added to his program, and then they will withdraw hours from that program. So anyone can be a member of a research program, a normal user. And this is one of the ways that people, say, collaborators overseas or students, etc., can get access to a research program. So if your advisor would like you to make use of CHPC for research, then all he has to do is sign up as a PI, establish a research program, and then add you. Okay, so that should be fairly straightforward. I will mention that the way to do this, to sign up as a user, and to find out a little bit more about our user policies, is to go to that very simple URL at the bottom, users.chpc.ac.za. Okay, so that's where you will do the sign up. It's a very lightweight, very easy process. It's not intended to keep people out from using CHPC. It's there to just keep the right people using CHPC and the resources going in the right direction. I expect it probably takes about 15 to 20 minutes for a PI to sign up. And typically the turnaround time before you actually have users on the system is within a couple of days. All right, how much does it cost? I hope everyone here is excited about that first line. I did highlight it in red. So if you're an academic user at a South African institution, okay, or someone is part of their research program doing academic research, I know it's sometimes a bit tricky because people often do work under contract or get commissioned for it, and then there's a bit of a question of how to deal with them, and it's normally a discussion with our management. But ultimately, otherwise, there is no cost. Okay, so no money changes hands. What we do ask the PI to do is every 6 months give us a report to tell us how that allocation was used. And this is literally so we can report back to DST what is their money being used for, how is CHPC supporting research in South Africa. Commercial users, though, we're also very, very keen to have you guys on our system. So if you're an SME in particular, we would love to see you making use of CHPC. And because you're making a profit, we obviously have to have you cover the cost to us. So that's basically electricity and depreciation. It typically works out significantly cheaper than if you went out to Amazon or Google Cloud or Azure. And if you look at the current rates, and remember this applies only to commercial users, we charge 45 South African cents, okay, per core hour. And also the GPUs are billed at the phenomenal rate, I think. Remember, these are V100s at 40 times the rate for a CPU. Okay, so that's much, much cheaper than you're going to get if you go out to Amazon or someone else. All that we require is that you sign a very simple MOU. It's quick and easy. It's typically about 2 pages. Just tells us what are you doing. So we don't support, unfortunately, production work, but we support a lot of R&D. So if your company is trying to develop a product, 100% CHPC is one of the right places you should look at if you need computational resources. All right, any questions about that?
So you mentioned you guys support more R&D. Are there plans for like production support? Because we do have a concern that you want to make use of these resources. And I see you guys are cheaper than...
Yes, unfortunately, because we're funded by the DST, this is all aimed at getting research done, development done. So unfortunately, when you move to the point where this is now just a production system, then you need to find another way to do it. Okay, so I think unfortunately that's just a limitation which is imposed on us by our contract from DST. So the mechanics of actually running jobs at CHPC. And this again is something which is not that difficult. I don't know why it tends to provide such a bottleneck or such a mental block to people. Most of the questions that newbies have are, I should say new users, are answered in quite some detail in our wiki, and I've given that link up at the top. The users basically log on to a head node. So from the internet, you connect to a head node, which is just one of the nodes in our cluster. but it serves as effectively as the portal in. And from there, you guys will have to write a script. Okay, and the script is basically just something that tells our scheduler what resources your job needs, and then how to start your job, what to do with the output files, and so forth. So all of the resources in the cluster are managed by a scheduler. So that just looks out and says, with 1,368 nodes, you've requested 5 nodes with GPU in each one. When does this resource becomes available? The first one in the queue that needs it will be assigned to that. The job will automatically be started on those nodes. So it just manages the resources for you, and you basically have to give it just enough information that it can figure out how to do that. So the jobs are started automatically. When the job is finished, then you're welcome to inspect the output. You can run interactive jobs as well, and sometimes people do this. There are times when you want to, for example, do a visualization. You maybe want to do some exploratory work on some of your output, and that's fine as well. So we do have a way to run an interactive job which will give you a session immediately on a particular node. We also ask that you use our ticketing system. So we have a number of staff there that look after users, and the goal is that we would like to do this as efficiently as possible. So if you use our ticketing system, then a question comes through. I forgot my password, seems to be the most common one, unfortunately. But again, we'll have someone who's able to resolve that as quickly as possible, or pass it on to the right staff contact. So another thing is you pass on a contact through an email. You might find that that person is, like me, no longer employed there, or you might find that they're on holiday. So the ticketing system really is our preferred way of interacting with our users. And this is for anything from software installs, through problems that you have with your jobs, to questions even about sometimes the science that you're trying to do. And that's very simple. You can interact with it both through the user database, which was the URL I gave before, users.chpc.ac.za, where you sign up as a user, whether you register as a PR or register a research program, or you can simply send a message, a standard email to helpdesk@chpc.ac.za, and that will automatically create a ticket for you. So this is where I think it's important that if you're interested in using CHPC and you'd like to see us get more machine learning resources in the future, it's very important to make use of us, because one of the ways that we figure out what the next generation of machine is going to look like is simply by the usage patterns that we see. So CHPC, as I said before, is very much driven by user demands or user requests, but we also look very carefully at what users actually do. So if you would like to see more resources dedicated to machine learning, I know that CHPC is more than eager at this point to support machine learning users. Then if we see a large uptake on the GPUs, then I can guarantee that the next time they look at an upgrade, the first thing that we're going to be looking at is how can we get more GPUs. At the moment, they are significantly underutilized, and that's a little surprising. But again, as I said when I started the talk, we unfortunately are, I think, South Africa's best kept secret. So especially if you guys fall into that academic category or the Government Science Council, there's no charge to use us. There's really no reason not to check us out. Thank you. Are there any questions?